The ocean floor did not stop accumulating things when we stopped looking. It continued, as it always has, in the cold and the dark and the pressure, receiving whatever arrived and keeping it with the patient indifference of a surface that has been doing exactly this for 4.5 billion years. The inventory examined in the first account of these unexplained objects, the Baltic Sea anomaly, the Yonaguni monument, the Bimini Road, the Cuban underwater structures, the polymetallic nodules and the cosmic spherules and the unresolved sonar contacts of the southern Indian Ocean, was not complete. It was a beginning. The ocean floor is not a finished catalogue. It is an open one, with no index and no final page, and the entries added to it by subsequent surveys, by sonar passes over poorly mapped regions, by remotely operated vehicles that went looking for one thing and found something else entirely, by expedition teams who descended with specific hypotheses and returned with evidence that their hypotheses had not prepared them for, are as strange and as resistant to easy explanation as anything that came before them. The ocean floor does not organize itself around the categories of human understanding. It holds what it holds in the sequence in which it received those things, without regard for whether the humans who eventually find them will be able to explain them or not. What follows is the continuation of that account, the second chapter of a story that the ocean floor has been writing since long before any human hand was available to transcribe it, and that will continue long after the current generation of instruments has been replaced by better ones. The underwater ruins off the coast of Dwarka on the western coast of India in the Gulf of Kambat represent one of the most significant and most contested submerged archaeological discoveries of the late 20th century. In 2001, the National Institute of Ocean Technology of India was conducting a routine pollution survey of the seabed when the equipment returned images of large geometric structures on the seafloor at a depth of 30 to 40 meters. Regular formations, linear arrangements, what appeared to be walls, streets, and the outlines of buildings extending across several square kilometers. Subsequent investigation recovered artifacts, including pottery, beads, sculpture fragments, and a human tooth. Radiocarbon dating of the associated organic material produced dates of approximately 9,500 years before the present, well before the earliest known urban civilizations anywhere on Earth. If the dating is correct, the implications would require a fundamental revision of the timeline of human civilization. The archaeological community has approached the findings with serious interest and serious caution. Some researchers argue that the organic material dated may have been transported by river currents and may not be contemporaneous with the structures. Others argue that the structures themselves could be natural sandstone formations. What is certain is that geometric structures exist on the floor of the Gulf of Kambat. That recovered material has produced dates of 9,000 years, and that the explanation, human settlement, natural formation, or some combination, has not been definitively established. The ancient submerged town of Pavlopetri, lying in 3 to 4 meters of water off the southern coast of Greece, is remarkable not as a mystery, but as a demonstration of what human settlements become when the sea takes them. Discovered in 1967 and comprehensively mapped in 2009, Pavlopetri is the oldest confirmed submerged urban settlement known to archaeology, dating to approximately 5,000 years ago during the Bronze Age. The streets of Pavlopetri can be followed. The walls of individual buildings can be traced. The spatial organization of the settlement, where people lived, where they gathered, where their dead were buried, can be reconstructed from what the seafloor has preserved with a completeness genuinely rare in archaeology. Pavlopetri demonstrates that the transition from dry land to seabed can preserve rather than destroy the evidence of human life. And it suggests, by extension, that the shallow coastal seafloor of the Mediterranean and other seas around the world contains a quantity of submerged human settlement. Bronze Age and Neolithic and Mesolithic towns and villages now lying underwater. That has not yet been systematically surveyed, and that is waiting, intact in the sediment, for the attention that would find it. The Atlantis Bank, a submerged plateau in the southwest Indian Ocean, rising from the abyssal plain to within approximately 700 meters of the surface, has puzzled marine geologists since it was first systematically studied. The rocks recovered from the Atlantis Bank during scientific drilling operations include large quantities of lower oceanic crust and upper mantle material, gabbros and peridotites, brought to relatively shallow depths by tectonic rifting at the nearby southwest Indian Ridge. But among the recovered material, researchers have found rocks whose age and composition resist explanation within standard models of oceanic crust formation. Some material from the Atlantis Bank appears significantly older than the surrounding oceanic crust, suggesting the bank preserves fragments of an older geological terrain uplifted and exposed by rifting. The presence of anomalously old and compositionally unusual material at a location and depth that does not fit standard geological models has produced ongoing research and ongoing scientific debate. A mystery in the rigorous sense, a geological feature whose formation history does not fit comfortably within current models of how ocean basins form and evolve. The Great Blue Hole off the coast of Belize, approximately 300 meters in diameter and 125 meters deep, formed during the ice ages when it was a dry land limestone cavern. When sea levels rose, the cave flooded and the roof partially collapsed. The stalactites hanging from its walls, stalactites that form only in air, are physical evidence of this history, geological time markers of a world before the sea came. Below approximately 90 meters, the water becomes anoxic and decomposition has essentially stopped. A 2018 expedition descended to the bottom and found a thick layer of hydrogen sulfide at depth, below which the preserved remains of animals that had descended and died lay intact in the extreme low oxygen environment. The geological formations in the lower cave, made when it was above sea level in conditions radically different from today, record ancient atmospheric and geological history that cannot be found intact anywhere else in the region. The Great Blue Hole is, in its preserved deep interior, a sealed archive of a world the ocean floor has been keeping undisturbed since long before any human expedition had the technology to descend and open it. The pyramid-shaped structure reported from the Atlantic seafloor near the Azores in 2013, described as a perfectly symmetrical four-sided formation at approximately 40 meters depth with a 60-meter base, attracted significant international attention before geologists attributed it to natural volcanic geology. The Azores are entirely volcanic in origin, sitting on the mid-Atlantic ridge, and the columnar jointing and erosion of volcanic basalt can produce regular angular forms that appear geometric in sonar images. The Portuguese Hydrographic Institute stated the formation was consistent with natural volcanic basalt processes. The formation has not been subject to close physical examination at sufficient resolution to definitively determine whether its apparent symmetry is natural or otherwise. It sits on the floor of the Atlantic under 40 meters of water, not definitively identified, not definitively dismissed, another entry in the catalogue of formations that the ocean floor has produced and that the instruments available have not yet fully resolved. The ancient shores of the Black Sea conceal what may be the most archaeologically significant collection of submerged human settlements anywhere in the world. Below 200 meters, the Black Sea is entirely anoxic, and in these oxygen-depleted waters, organic material does not decompose. Ancient shipwrecks found here retain intact wooden hulls, preserved rigging, undisturbed cargo, a degree of preservation impossible in oxygenated ocean water. Approximately 7,500 years ago, the Black Sea was a freshwater lake surrounded by human settlements. The catastrophic flooding through the Bosphorus, Mediterranean salt water forcing its way in as global sea levels rose, drowned those settlements. Archaeologists Robert Ballard and Frederick Hebert found submerged structures and artifacts on the Black Sea shelf consistent with habitation sites drowned by the flooding event. What the deep anoxic waters preserve of the settlements inundated in that flood has not been fully investigated, because the technology required to excavate at significant depth in anoxic water is only recently becoming available. What it will find when it finally reaches the bottom and looks at what was left there 7,500 years ago is genuinely unknown. The Silfra fissure in Iceland, where the North American and Eurasian tectonic plates pull apart at approximately 2 centimeters per year, contains some of the most geometrically striking underwater geological formations on Earth. The walls of the fissure rise on either side with a precision that suggests construction rather than geology. Flat vertical faces of volcanic basalt, separated by extraordinarily clear glacial meltwater, visibility extending over 100 meters in water so pure it requires no filtration to be drinkable. Silfra is not a mystery scientifically. Its origin is thoroughly understood, its geology thoroughly studied. What it represents in this account is a reminder that the most apparently artificial-looking underwater formations can have entirely natural explanations, and that the human tendency to interpret regular geometry as evidence of intention is a cognitive habit that underwater environments exploit with particular force. When rock fractures along clean plains and those plains fill with perfectly clear water, the result is something the human visual system interprets as construction. It is not, but the experience of moving through it, passing between walls of volcanic rock at the precise boundary between two tectonic plates, in water so clear the distance creates no distortion, is unlike anything else on Earth. The seafloor deposits of fossilized megalodon teeth collected from various locations in the Pacific, Atlantic, and Indian Oceans sit at the intersection of paleontology and marine geology. Megalodon, extinct for approximately 3.5 million years, left its mineralized teeth on the ocean floor, where they sink, become buried, and persist for millions of years. The distribution of these teeth is not uniform, and concentrations found in certain areas of the Pacific abyssal plain, areas where teeth are substantially more abundant than surrounding regions, are not fully explained by what is known about megalodons' distribution or behavior. Some researchers suggest these concentrations reflect ancient hunting grounds. Others propose that oceanographic factors, bottom currents, sediment accumulation patterns, transport and concentrate teeth from original deposition sites. The explanation for why concentrations occur where they occur in the densities in which they occur remains an active research question. The possibility that seafloor concentrations of megalodon teeth encode information about the behavior of a 3.5 million year extinct animal, preserved in cold, dark sediment since long before our species evolved, is one of the more quietly extraordinary implications of deep-sea paleontological research. The Nazca Ridge, extending across the eastern Pacific from the South American coast toward the Central Pacific, is a remnant of the Nazca Plate's passage over a mantle hotspot, an elongated plateau of thickened oceanic crust produced by volcanic activity as the plate moved over a fixed point of elevated heat beneath. The seafloor of the Nazca Ridge contains unusual flat platforms at various depths, topography more complex than a simple hotspot track should produce, and rock formations whose ages do not always correspond to the expected sequence of hotspot volcanism. Some sections contain formations that appeared in lower resolution sonar surveys to have an organized or artificial character that higher resolution investigation has attributed to geological processes. The ridge has not been comprehensively surveyed, and its deeper sections remain poorly mapped. Named for the Nazca civilization of Peru, famous for its desert drawings visible from the air above, the submarine feature bearing that name has attracted far less attention despite containing geological puzzles that marine geologists consider genuinely open questions about how oceanic plateaus form and evolve. The deep-sea glass sponge reefs, discovered on the continental shelf of British Columbia in 1987, exist in a category of scientific significance, defined by what was thought to be true before they were found. Glass sponges, sponges whose skeletal structure is made from silica, biological glass, were known from the fossil record as dominant reef-forming organisms from approximately 500 million years ago until about 100 million years ago, at which point they largely disappeared from the fossil record and were assumed to have gone extinct as reef formers. When researchers discovered enormous living reefs of glass sponges extending for tens of kilometers along the British Columbia shelf at depths of 150 to 240 meters, the discovery required a revision of what was understood about this group's survival through deep geological time. The reefs have been accumulating since the end of the last ice age. Their ecological importance as habitat, as water filtration systems of enormous capacity, was entirely unknown because they were believed not to exist. Their discovery is a reminder of how significantly the absence of information can distort understanding of what lives in the ocean, and how much of that understanding is constructed from evidence that is fundamentally incomplete. The methane blowout craters documented on the seafloor of the Barents Sea and other Arctic continental shelves represent a recently recognized category of seafloor feature whose implications extend beyond their unusual appearance. Methane hydrates, ice-like compounds of methane and water stable at the temperatures and pressures of the deep sea floor, form solid deposits within continental shelf sediments worldwide. When temperatures rise or pressures drop, the hydrates destabilize and the methane they contain is released, sometimes explosively, creating craters hundreds of meters across in the seafloor. When approximately 500 such craters were identified in Barents Sea sonar surveys in 2015, some researchers initially proposed impact sites or unknown structures before the correct methane blowout explanation was established. But the implications remain actively researched. The timing of original blowout events, the rate at which new blowouts may occur as ocean temperatures rise with climate change, and the total quantity of methane held in hydrate deposits globally are open questions whose answers will matter significantly for understanding the future stability of the sea floor and the chemistry of the oceans above it. The Dragon Triangle, the region of the Western Pacific between Japan, the Philippines, and Guam, sits at the junction of several tectonic plates, and the seafloor geology reflects this complexity in ways that remain incompletely understood. Sonar surveys have documented circular depressions, unusual ridge features, and areas of seafloor topography that do not fit straightforwardly into the known tectonic history of the region. The surveys of this region have been less comprehensive than those of more heavily studied ocean basins, and the geological complexity makes it difficult to attribute observed anomalies confidently to any single process. The disappearance of ships and aircraft in the Dragon Triangle has a straightforward meteorological explanation in the violent weather of the Western Pacific typhoon systems and in the volcanic and seismic activity of this highly active region. But the seafloor beneath the mythology contains real geological features that geologists have found genuinely interesting and have not fully explained. In water that remains less well surveyed than the attention it receives in popular accounts would suggest. Somewhere in the dark beneath this region, in geology still being mapped and still being understood, there are features the available surveys have recorded and have not yet accounted for. The ocean floor keeps them, as it keeps everything it has ever received, in the cold and the pressure and the dark and the silence, patient with the patience of deep geological time, waiting for the attention that would finally, carefully and without preconception, determine what they are and how long they have been there, and what the long patience of the ocean floor has preserved that we have not yet thought to look for.